All right, so our next topic is going to be over how to calculate weighted atomic mass. And that has to do with your M&M's lab. So you know there are a number of isotopes for elements, because an isotope is an element that has a different number of neutrons inside the nucleus. And so when you figure out the weighted atomic mass, it has to do with the abundance of the element. So there is a sweet site that gives you all kinds of information about elements and how abundant they are. And for example, if I look at boron, the information for boron, it gives me two isotopes, boron 10 and boron 11. Boron 10 means that it has 5 protons and 5 neutrons. Boron 11 has 5 protons and 6 neutrons. So, and then as you see, the abundance of B10, it's less abundant. It's about 20%, whereas boron 11 is more abundant. It has about 80% abundance. And so the way I would write it out is, so my isotope B10, I'm going to just keep 4 sig figs, so 2 places after the decimal. 1001 is my atomic mass unit, or you can think about the mass in atomic mass units. It's 10.01, and I write down the abundance, 19.80%. And then my second isotope is B11, and the atomic mass is 11.01 atomic mass units. And here's my abundance. So to figure out my weighted atomic mass, what I need to do is I'm going to take the mass of this particular isotope and I'm going to multiply it by this turned into a decimal, and then add this mass multiplied by this abundance also turned into a decimal. So I'm going with, that's my mass in atomic mass units, that's my abundance in decimal, 11.01 is my other mass, and that's my other abundance, 0.8020. So that gives me, my calculator will give me this. However, when I look at my sig figs, this only had 2 decimal points. So my answer can only have 2 decimal points. So my weighted atomic mass will be 10.81 atomic mass units. Do not forget your units. You always have to include units, because this is not just math, this is science. And science has to deal with units. And actually, if I look at the periodic table, what I see there for my atomic mass is 10.8. And you can think about it this way. My more abundant isotope is the one that has almost 80% abundancy, and its atomic mass was closer to 11, and my atomic mass here, when it's weighted, is closer to 11. It's 10.811, and the reason why I got 10.812 is because I went ahead and actually under-rounded it here, but then over-rounded it over there, because I said 11.01, where this is actually 11.009, la 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 la. So again, if you go to 2 decimal places, then my answer is exactly what it shows in the in the periodic table. So again, when you're figuring out weighted atomic mass, you will be given actual masses in atomic mass units, and then you will also have the abundance in percent. So the first thing you do is you turn your percent into decimals by moving your decimal points twice, or dividing by 100 if you will, and then you take each mass multiplied by abundance and you add all of them, and then again you look at how many decimal places you have, because when you add, that's what you pay attention to. So decimal places, 2, my answer has 2, I'm good.